So adding and subtracting radical expressions is very similar to just adding and subtracting polynomials. So what is 6x plus 5x? 11x, okay? If you know if you know that 6x plus 5x is 11x, this is not much harder than that, okay? You have to think of the radicals in a way as like a variable. So for instance, they show here that if I add 2 square roots of 5 plus 4 square roots of 5, then basically all you're adding is kind of like having an x here. So it's like saying that this is 2 plus 4 times the square root of 5. So adding them together, you get 6 square roots of 5. Okay? Subtracting them, same way. Right? 6 square roots of x minus 2 square roots of x. What's under the radical is the same. As long as they're under the same, or they're the same, then I can add or subtract them together. Up here they show us some like radicals and some that are not, that are unlike. Okay? What's under the square root sign has to be the same. If it's the same, you can add and subtract them. If they're not the same, then obviously you cannot. Okay? Sometimes we will have to do some simplification to get there to make them look the same, but most of the time we won't have to do that. Or I should say, I can't say that. So letter A, 9 square roots of 3 minus 4 square roots of 3. First thing we're looking for is what's under the radical. Can it be simplified? Okay. So number one, first thing we look for. Number one, can the part under simple. Okay, we're looking for that. Can the part under the radical be simplified? In this case, 3 is as simple as it can be, right? There are no squares that go into 3. Okay, so since they're the same, then what do you get? 5 square roots of 3. Oops. Oh, hey. 5 square root of 3. Okay? Letter B. Can we simplify what's under the radical in either case? Okay, no. All right, are they like radicals? No. And if they're unlike radicals, then that is your answer. They cannot be simplified. That would be just like if I said 6x plus 8y. Can I add together 6x plus 8y? No. Okay? They're unlike variables, can't add them together. Same with unlike radicals. You cannot combine them. Okay. Letter C. Square root of m minus 7 square roots of m. Okay. Dylan? Yep. We have 1 here, and 1 minus 7 is negative 6 square roots of m. If the radicals are what's under the radical is the same, then you can combine them. Now here we have, for letter D, we have 3 terms. And we have to look to see if any of them have like radicals there. So this one here and this one here both have xy under the radical. So that makes them like radicals. This one here only has a y, so it's different than them. So I can combine the 2 with the xy together. So 2 plus 9 is 11. So we have 11 square roots of xy plus 2 square root of y. And that's it. We cannot combine them then. The easy stuff's always nice, and they just have to make it more complicated, don't they? Okay. So those are pretty easy. All right, you just check out the radicals, make sure they're the same. If they're the same, you can combine them. If they're not, then you can't. Okay. But sometimes they have to be simplified first. And it's very important that we understand that when we have a number in front of the radical, if I have 7 square root of 5, okay, it's important that you understand that this means multiplication. All right, that's like saying 7 times the square root of 5. There are times where sometimes we get confused. Okay. All right, so we have square root of 45 and minus the square root of 20. Okay. So first of all, we look at them. Can I simplify the 45 and the 20? Okay. Is there a square? Or what's the largest square that goes into 45 from here? Which one? Okay, 9 goes into 45, right? How many times does 9 go into 45? 5 times. So I can rewrite this as the square root of 9 times 5. What about 20? What's the largest square that goes into 20? 4 does. Okay. So this is the square root of 4 times 5. Now, how many of you are getting comfortable right now of writing the answer from here without going to the next step? Okay, how many of you? Hopefully quite a few of you are, right? Okay. All right. Now, I can rewrite these then using the product property. Square root of 9 times square root of 5 minus square root of 4 times square root of 5. Okay. Now, if you're getting comfortable doing it going from here to this step down here we haven't done yet, then that's fine. You don't have to do this step of writing it in separate square roots. So square root of 9 is 3. So we have 3 square roots of 5 minus the square root of 4 is 2 square roots of 5. So are these two things the same now? Okay. I have a like radical now. 3 minus 2 is 1. So this just equals the square root of 5. Okay. So we're taking what you did the last couple days with simplifying the radicals, and then we make them into an addition or subtraction problem. So for letter B, we have 9 square roots of 75 plus 2 square roots of 50. Now, this is where it's very important that you understand that we have multiplication. When I say 9 square roots of 75, it means I'm multiplying them. And that's important you understand that, because what happens is we're going to end up in a situation here where we're going to have another number added in there. And some people tend to add those numbers instead of multiplying them like you're supposed to. Okay? So, 75. What's the largest one of these squares that goes into 75? 25 does? Okay. So we can write this as 9 times the square root 25 times 3. And how about 50? What's the largest square that goes into 50? 25 also. Okay, so that's square root of 25 times 2. Now, this is where it's important to understand the multiplication. So the square root of 25 is, okay, so this is 9 times 5 times the square root of 3 plus 2 times 5 times the square root of 2. Yes, sir.
Can you do it the other way? That way the radical goes in. So they're both square root of 5.
Could I do that? Are you sure? All right. All right, let's check out what Dylan wants to do here. So if I write it the way he wants it to be 15 times 5 plus 2 square roots of 10 times 5, right?
Well, like put 25 under the radical, so that it's the radical of 5 and times 3 times 9 and 2 times 2.
No. No, because what you're trying to do is when I write 75 as a factors, okay, it's got to be 25 times 3 because one of them's got to be a square. Okay, when I take the square root of that, I get 5, which comes outside of the radical. Okay, it doesn't stay underneath. Okay, the only thing that stays underneath is going to be the 3. All right, because if I go back to this step, that this is 9 square roots of 25 square root of 3 plus 2 square roots of 25 square root of 2. Okay, I can simplify the square root of 25. I can't simplify the square root of 3. Okay. All right, so get rid of that. But some of you, okay, sometimes some of you do tend to do this, okay? And that you'll write it like that. Is that a true statement, what I've written over here in the black? Is this a true statement? Does 75 equal 15 times 5? Yes. Does 50 equal 10 times 5? Yes. Okay. All right. So it's a true statement. The only problem is that there are no squares here to be able to simplify it then. So that's why when I break these apart into factors, okay, one of those factors has to be a square, and we always want it to be the largest square we can find. So we have 9 times 5 square roots of 3 plus 2 times 5 square roots of 2. So we get 9 times 5 is 45. And this is what I'm saying, that sometimes where the problem lies is that people put plus sign here between the 9 and the 5 and add them together instead of multiplying them together like they're supposed to be. So 45 square roots of 3 plus 10 square roots of 2. Okay. Now, can I simplify that? No, you can't, because the radicals are not the same, so that's your answer. Okay, letter C. Now we're going to throw a variable in there. Okay. Sometimes it gets a little bit confusing when they throw a variable in there. Okay. But in reality, it's no different than if it's a number. Okay. If we look at all three of them, they all have y, right? Okay. Can I simplify the square root of y? No. If it was y squared, I could, right? But not with y. So I'm looking at them, and I can see that they all have y in them, that it's just a y to the first power. It's going to be there when I'm done. So I can go about this problem without the y's bothering me, because I know that when I'm all done, I'm still going to have y under my radicals, because that can't be simplified. But it's the numbers then I need to worry about. 75. Oops. So we got 75 and 27 and 48. We're going to simplify all three of them. Okay. 75, hey, we just did that, didn't we? Okay. So this is going to be square root 25 times 3y. Now, I left the 3 and the y together because neither one of those can be simplified, can they? Okay, there's no square that goes into 3. There's no square that goes into y. Okay. So I can leave those together because they're prime. Minus 2 times the square root of. Okay, largest square into 27 is 9, so this is going to be 9 times 3y. Plus, right, square root of 48y. So 48, what's the largest square that goes into 48? Okay, 4 goes in it, right? But 16 also does. So we always want to take the largest one. So in this case, it's the square root of 16 times 3y. Okay. Now, how many of you are comfortable for moving on here? We don't need to pull them apart. Okay. All right. How many people like us to pull them apart and do right as separate things all the time? It's okay if you do. All right, Justin, sometimes. All right, so let's go ahead and do that. So we have the square root of 25, square root of 3y. If you don't need to go to this step, it's okay. Don't do it then. 2 square root of 9, square root of 3y. Plus square root of 16, square root of 3y. All right. So, all right, I wrote them as factors. Pull the factors that are squares apart using the product property. So this becomes 5 square root of 3y minus, and what's the square root of 9? 3. Okay, so this is 2 times 3 square root of 3y, and then plus 4 square root of 3y. So I look at what's under the radicals. 3y, 3y, 3y. They're all the same. Since they're all the same, I can combine them together. So this is 5 minus 6 plus 4. Okay. 2 times 3 is 6. Not 2 plus 3 is 5, but 2 times 3 is 6. So 5 minus 6 is negative 1 plus 4 is 3 square roots of 3y. Okay. So these are Just that same adding and subtracting. Okay? Just that you have to do some simplification first. Make sure that they can't be simplified before you move on. When they have a variable in it, if it's just to the first power, then that tells me when I'm all done, I'm going to have that in my answer too. All right. Little word problem here then. Find the perimeter of the triangle. Give the answer as a radical expression in simplest form. How do we find the perimeter of a triangle?
Oh, no, yeah, sorry, I'm sorry.
Okay, add up all the sides for perimeter. So 3 square roots of 20 plus 13 square roots of 5 plus 10. P, or perimeter, equals that. Can we simplify any of those radicals first? Okay. There's a couple that you should get very familiar with right away. Okay? 8 is one, 20 is another, and you'll probably see 48 a lot. Okay? These three you'll end up seeing a lot. Okay? 8, 2 square roots of 2. 20, 2 square roots of 5. 48, 4 square roots of 3. Okay? Those are pretty popular ones that you see. Okay? And once you get used to seeing them, okay, well, since if I know that square root of 20 is 2 square roots of 5, okay, then it's okay for me to just plug it in there. Okay? All right? Because remember, this is square root of 4 times 5, and the square root of 4 is 2. Okay? So we have 3 times 2 square roots of 5. Can't simplify the square root of 5, and just 10 is 10. So we multiply 3 times 2 and we get 6. So my final answer then would be 19 square roots of 5 plus 10, and this is millimeters. So make sure you remember to put the units there. So combining two things that we've done, simplifying radicals and adding and subtracting like expressions, okay, with like terms.